right, I just started the recorder. I'm hoping most of you have gotten started with your homework assignment, because it's going to take some time to get it done. Okay, so you got to get it started, just so that you have enough time to work on it. So, are there any questions from those of you who have started to work on the homework assignment and you are hitting a snag or something like that? Are there any questions about it? Yep.
Can you kind of like go over the code, like how it goes and what function it calls? Because sometimes I really have problems with connecting the functions together.
Okay. Well, I can go over the description of the homework assignment.
Yeah, sure.
And the homework assignment is, the description is mostly in the file itself. Okay, so when you look at, when you read mmgame.h, which is the header file, the comments, is basically, telling you what each subroutine is supposed to do. I'm just, shrinking the screen so that it fit kind of, I suppose it won't work that way. Okay, this is the best I can do. Okay, so there are 3 subroutines that you have to write here. The first one is generate hidden, which is to generate the hidden pattern. So instead of reading the hidden pattern from standard input file, you're going to use a random number generator to generate the random pattern. Okay. For testing purposes, at least initially, you can probably just hard code it so that it is always a particular pattern. That makes debugging easier, but just make sure that when you turn it in, it is randomized. Okay. The second one is game reset. It is just basically resetting the entire game, and the only thing you need to do is to, well as the comment says right here, reset guesses used counter. So when I say reset, it means clearing it or making it 0, basically. The most difficult one, which is not really difficult, is game guess. So what it does is the following. So first of all, it should check to see if all the guesses are used. If so, return the value of 2. So how do you know that you have used up all the possible guesses? You look at the member called guesses used, and you compare that to
how many guesses they gave.
Yep, game length, which is the constant, right? So if it is not there yet, okay, if there's still room for at least one more guess, then you will proceed to the following code. Okay. If there is at least room for another guess, then what you need to do is you have to score the guess that is passed to you. So you can see that from the 2 parameters, one parameter is a pointer to a game, the other parameter is a pointer to a guess. So what you need to do is to score it first. The game structure has the hidden pattern, so you have everything that you need to use. You need to use in order to call score, which is the subroutine that we did from the previous homework assignment. Then you want to copy that to the appropriate entry in the array that keeps track of all the previous guesses. There's only one array like that one here, and it has to do with this one. Okay, so guesses is an array in a game so that you can keep track of all the previous guesses. And then after that, the counter should be incremented, so you remember there's one more guess used in a game. If the guess pointed to by p guess matches the hidden pattern, then you want to return a value of 1 to basically indicate, okay, the game is concluded because you have gotten the actual hidden pattern. Otherwise, you return a value of 0 to basically say, no, it's not concluded yet. So when this subroutine returns a value of 0, it means it's not concluded yet. Go ahead and ask the end user to enter another guess. If it returns 1, it means it is concluded because the player has already guessed the hidden pattern. If it returns a value of 2, it means all the guesses have been used. Okay, okay, is that helping? Okay. So that's the description of the homework assignment. Are there any other questions related to this homework assignment? No other questions? Yep, go ahead.
So I know you're supposed to score the store the past guesses that you've made, but is that going to be like printed out in the program or anything like that, or is that just going to be behind the scenes?
Which part? The scores?
Where part of Game Guess, I believe, was storing. If there's still room for another guess, Game Guess should first score the guess, point the guess, then copy it to the appropriate entry in the array. So it's copying your guesses. Is that going to be seen by the is that going to be seen by the user?
There won't be any type of input-output as far as the user is concerned.
So it's just going to be able to be seen from like debug.
Yeah.
Okay.
Yeah. It's all happening internal to the structures, to the variables.
All right.
All right. Any other questions? No other questions? All right. Just also as a I kind of said it already on Monday. This is my solution to the mastermind mastermind scoring homework assignment. So for those of you who did not quite get it done, in the scoring part of the homework assignment, even if you got it done and you kind of feel that, well, I'm not 100% sure my scoring function is correct, you can use mine. Okay, so you can just download mm.cpp and use it in your new homework assignment. Yeah, that's not a problem. Are there any questions about this homework assignment? Okay. If there are no questions about this homework assignment, I will go back to talk about C strings, and we'll go ahead and implement one of the C string functions. We got a few things done already. Okay, so this part is what I left for myself. In class demonstration is to write string copy, string and copy, string compare, and string and compare. These are all what we call standard C string functions. In other words, they are all predefined. Okay, they are already in a library. Every time you need to compare a string or copy a string or do anything like that, there is no need to write your own subroutine because they're all already done. But for the purpose of this class, I do want to write all of these, some of these subroutines, not all, just so that we can take a look at how do we deal with arrays, how do we deal with strings, and so on, or algorithms in general. What I'll do today is to write a subroutine that is neither string copy or none of these four. Okay, what I'll do is to write a string function. Okay, you heard it right. The name of the subroutine is string str, or stir. Okay. So we'll go ahead and read the documentation first, because this is a very important part of writing a program or developing anything, because you've got to make sure that you know what is expected out of the subroutine before you get started with the subroutine. Okay, so this is what we want to do, not the second one, but the first one. Okay, stir. So stir takes two parameters, and it returns a pointer to a character. The first parameter is called haystack, and the second parameter is called needle. So for those of you who know idioms and stuff like that, what is this suggesting?
Finding a needle in a haystack.
Finding a needle in a haystack. Okay, so one is representing an area where you can do the search, and the other one is representing what you are searching for in the haystack. Is that okay? So we are looking for the string called needle in haystack. So let me give you some examples first. Okay. So if I have tag audio, which is my name, okay. So if this is the haystack, okay, this is basically where you're going to do the search, and the pattern that you're searching for is AK. Then the answer is yes. AK is what we call a substring in tag audio, because this part is the substring that we are looking for. The substring that you're looking for may or may not be at the very beginning of the entire string. It can be anywhere in the middle as well. Is that okay so far? Okay. So let's take a look at the description of string and find out how it is described here. The man page is a very useful type of document, because for one thing, you can use the man page to find out what functions are already implemented in the standard C library, so that you don't have to rewrite things that are already there, and you don't need to go ahead and rewrite it. But the second thing that is really useful about the man page is it also describes what these functions do, and so because you need to know that in order to make use of these functions. So let's go ahead and read description. The stir function finds the first occurrence of the substring. Okay, I made this text box a little bit too wide, and it does not. Well, I guess it does. Okay, it just kind of wrapped around the text here, which is not the best, but the text is large enough so that people in the back can see it too. So the stir function finds the first occurrence of the substring needle in the string haystack. The terminating no bytes are not compared. In other words, there is an implicit no terminator here as well as one over here, but those are not really compared in this case. The next one we don't really care about because we are not doing the case insensitive search. We are doing a case sensitive search. Return value. These functions return a pointer to the beginning of the located substring. In other words, if this is the haystack and this is the needle, what the subroutine is supposed to return is the address of this byte. Are we doing okay so far as as far as the return value is concerned, what it is returning? Yep.
Does it return how long the matching section is, or just?
No,
okay.
It has to match entirely.
Okay.
There's no partial match, okay? If nothing is matching, then the next sentence applies. It returns a value of null, which is a zero pointer, okay? A null value is basically just a zero. It returns 0 if the substring is not found. So if the substring is not AK, but AK47, then it's not found, right? Then stir is going to return null. Okay, is that okay so far? What if I'm searching for? I'm looking for something that has two occurrences. U occur twice, so I'm just looking for a string that only has one character, okay, which is U. And you can see that in my name, U appeared twice, both lowercase, right? According to the documentation of stir, which one is it going to return? The address of which is it going to return? The first one, right? So that means it will return the address of this particular U, even though there is an additional one later on. It's not going to return the second one. It returns only the first one. Are we doing okay so far? Are we doing okay as far as the description of stir is concerned? Yep.
What if you switch for KA without the space?
Without a space in between, then it won't match because the space character is a character. So as far as a string is concerned, K is one ASCII code, the space is another ASCII code, and uppercase A is yet another ASCII code. So if you're looking for just lowercase k and uppercase A, there's no match. There won't be any match for this one. Okay. Are there any other questions? No other questions? Okay. So with this one, we could write a program to test it, just to see what stir is supposed to do in the actual stir. Okay. But that is not a luxury when you are implementing a new function that has not been implemented before. So I'm not going to run a test on stir. Instead, what I would do is actually go ahead and implement the subroutine and think about how to implement the subroutine too. Okay, because that really is the most important part. Is how do we approach the problem? How do we design and write an algorithm that can solve this particular problem, looking for a substring in another string? Okay. Is that doing okay so far? Okay. All right. So let's think about it. Okay. When we think about this, we are not going to write any code. Some people can write code as they think about the solution of a problem, and they can basically start to synthesize the code in C without having to go through, I'm going to go through a few examples by hand first. It is not recommended. That approach does work on some people, especially people who are kind of more have what we'll call have a knack of programming. Okay, But it's not really recommended, because even for people who are really proficient at programming, when they start doing something like that, it means they're not thinking through all the different scenarios. And sometimes it can lead to a quick but not entirely correct solution. And those are some of the worst kind of problems that you can have as a developer, is to make some code that works most of the time but does not work all of the time. So what we'll do is I can use a spreadsheet to illustrate how to do things. So let's go ahead and use a spreadsheet to do this. The nice thing about the spreadsheet, which is under Office, is I can show you the whole process. So let's go ahead and all right, so let's go ahead and just use the example that we have on the whiteboard. So column A is going to represent a haystack. Here, column B is going to represent needle, and column C is going to, well, we'll just leave column C not really commented at this point. So the haystack is just my name, T-A-K-A-U-Y-E-U-N-G. There we go. And the haystack is AK. Okay, so let's look for AK in this case. So AK. And in both cases, there's an implicit null terminator. Even though the documentation says that the null terminator is quote-unquote not compared, it simply means that we do not need to match the null terminator. Because if the null terminator is going to be matched, then the substring can only be the last portion of the haystack in order to have a null terminator at the end. So that's what it means when they said the null terminator is not matched. But it is used to determine when the substring is fully matched. Everything okay so far with that? Okay. All right. So how would you go about doing this? Okay, knowing that haystack is this pattern and needle is AK and then a null terminator. How would you go about doing it? Well, you would start with the beginning of the entire haystack, right? So you would try to match the entire haystack, the beginning of the entire haystack to the first letter of needle. And do we have a match here? We do not have a match. Do you think I need to compare the next character? No. So this means, this position cannot be the beginning of a match. Is that okay so far? In other words, when you are comparing a part of the haystack to the needle, as soon as you find something other than the null terminator that is different between the two strings, you can stop and say it's not here. Okay? All right, so let's move on to the next character, which is A here. But remember, every time you do not have a match, you have to reset the counter or reset the pointer back to the beginning of needle. Because needle is already partially matched, so you have to reset it back to the beginning so that you start from the beginning of needle again. This time A and A, they do match up. So when you have one character matching up, then you have to go for the second character or the next one. K and K also matches it. Are we going to compare the space character to the null terminator? We're not going to compare that. And to guard against comparing anything with a null terminator, it simply means that when you are encountering the null terminator in the needle, it's time to quit. It's time to say, I'm done. Okay, the entire needle is matched and there's nothing else that I need to do. But you do need to keep track of where it started, because the pointer or the address of this letter A is what is going to be the return value of stir. Are we kind of doing okay so far with understanding how to do this by hand? Okay. I can give you another example. So let's get rid of this particular needle, and this time we look for a single letter U. Well, let's make it UN. Okay, so UN and a null terminator is in the needle. Okay, this is going to be a little bit longer. Okay, because what we'll do is we'll go ahead and start from the beginning. T, U do not match. Okay, let's move on to A. U does not match. K, U does not match. Space U does not match. A, U does not match. U, aha, they do match. Okay, so what you do now is to say, okay, one character is matching from the one letter from haystack is matching the same letter in needle. So what you need to do now is to move on to the next letter and say, well, let's take a look at the next one. U, Y, and N. Those do not match up. Okay, so now you can conclude as no, they do not match. The question is, where do you go to continue in the haystack? And where do you go to continue in the needle? What do you guys think?
You go back one in the haystack.
Yep, needle needs to rewind all the way back to the beginning. For the haystack, we move on to the next letter. Okay, so this is all the things. These are the things that you have to think about in your actual code. Now, when you're writing code like this, I would not try to write C code that would compile and work perfectly okay the first time. I would jot down some conditions and say, hey, these conditions seem to be important, okay? Because by doing this by hand, we kind of recognize that we have to compare a character from haystack to a character in needle. Sometimes we have to rewind needle. We have to remember where we were with haystack so that we can rewind back to a certain position for the next compare to needle. So those are the things that you have to think ahead of time, and just say that, okay, we need to do that. The ordering may not be determined yet. Y and U do not match up. E and U do not match up. U and U matches up. Then we move on to N and N. They also match up. But then the next one is a null terminator in needle, and this is the time when you can say, hey, we got a match here. We are all done. Is that okay? Then you have to think about the situation where there's no match. Okay, how do you know there is no match? So what you can do is to specify in needle something that is not there. Okay, so in this case, I'm just going to specify a single letter Z followed by a null terminator, because the letter Z does not appear in my name at all. So this is going to be boring for the first part, right? T, Z do not match. A, no, 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 and so on. So this is the second last character you'll be comparing. G and Z do not match. And then when you move on, then you encounter the end of string of haystack. This is signifying that the substring is not found anywhere in haystack. You should also get out of the loop in this case and say, it's not there. Are we still doing okay so far with this code here? Okay, so how would you structure your program? There are many, many ways to structure a program for string. Okay, you just have to kind of find a way to do it. How would you do it? You can even make use of another subroutine if you want to. You can make a subroutine. Well, we don't call it a subroutine, but you can just call it a subroutine that will be called by your own string function. Okay, if that would make things easier. So what do you think? How would you go about doing this?
Seems like it'd be 2 loops. Haystack is the outer loop.
Okay, you can do it with 2 loops. You can also do another subroutine. Okay, so what I'll do is I'm going to illustrate the top-down design approach, which is basically saying we'll do it the lazy way. Okay, so we'll start with pseudocode, and you'll see where we can go from there. So here's mousepad, and and when you're doing this, you don't need to use actual C code. You just have to use pseudocode in a way that what it means. Okay, so stir is going to take 2 parameters. One is called haystack, and the other one is needle. They're both pointers to characters. In other words, both of these parameters store the address of a character. And in the code here, you can basically say, so without specifying the details, this is how I would do it. You can say, for each position of haystack, try to match needle. Okay. If needle is matched, exit the loop, return the first position of the match in haystack. That's basically how it should be specified. And then you say if we are at the end of haystack, return null, which is basically just a 0. So it roughly identifies what we need to do. Okay, there's one thing which is called for each position of haystack. Okay, well that tells me something needs to remember where we are in haystack. Okay, we are currently looking at this position. We're currently looking at the next position, and so on. Trying to match needle, but needle is not a single character. Okay, so we're trying to match a string with a string from the position. So this particular match action is corresponding to this position here. In other words, for each position of haystack, starting from the beginning, we want to use that position as a start position in order to match needle. Is that okay? Right? And these two are basically exit conditions. If needle itself is matched, we want to get out of the loop. If we are at the end of haystack, we also want to get out of the loop, even though after we get out of the loop, in one case we have to return the address of the first position of the match in haystack. In the other case, we want to return just a null value, which is known as 0. Okay. All right. So from here, we will go take a look and say, well, that's not really exactly clear how we're going to do this, but there's one thing that we know, for sure. It's easy to control the position in a haystack, because what we need is to have an index that goes from 0 all the way to the end of haystack. Is that okay? Okay, so what we can do is to specify and say it's a haystack position variable. So the next thing I do is to say use hpos, okay, to remember which position of haystack we are currently at. Okay? Is that okay so far? Because I'm just using a particular variable to say, okay, how do we keep track of which position of haystack we are dealing with? Using a variable. Is that okay? Now that we know that we have a particular variable to remember which position of haystack we are currently at, we can actually start to write some C code. Okay? Because the typical way to specify, hey, we want to do this to every single position in haystack, that is not hard. That is just a for loop that goes like this. Okay? Position start off with 0. And how do we know that we are still in haystack? We have not moved past the null pointer of haystack, or the null character in haystack.
The position where hay position is not equal to null.
That's right.
Yeah.
So this would be at least one of the conditions to stay in the loop. Does that make any sense? Okay. And for each iteration, okay, because since I'm trying to do this part here for each position, so for each iteration, what am I supposed to do with hpos at the end of the iteration?
Add 1.
Just add 1 to it, right? Okay, very good. All right. Well, that's not a bad beginning. That looks like C code to me. It looks like it will basically go through the entire haystack one character at a time. Are we still doing okay so far with this code? Is that okay? All right. Okay. But this is useful because we have now taken care of the outermost part of the logic, which is still saying, okay, we want to do something for each position of the haystack. Okay, we got control over that now. So what we now want to say inside the loop here, I'm just going to use comments to indicate what I'm supposed to do here. What we want to do per iteration is to try to match needle at this position of haystack. Is that making any sense? Isn't that what we are supposed to do, to find the substring? Okay, and we want to find the first occurrence of the substring, so that's why we are going from the beginning of the string all the way to the end of haystack. Are we still doing okay so far with this one? sort of. Okay. Well, this is where top-down design is going to kick in and say, well, matching a string with another string is kind of a difficult logic, okay, quote unquote difficult logic to specify. So what I will do is I'm going to do a typical thing to procrastinate and assume the job is going to be done by somebody else. Okay? Well, that is actually a healthy kind of thinking when you are trying to apply top-down design. Not so healthy when you are really thinking that, hey, if I do this later, maybe I don't have to do it, or somebody else is going to do it. Okay, it's a good way to do it when you're just trying to structure your code so that it's not overly complicated. Okay, so what I'll do is I'm just going to assume that there is a subroutine to do this part. Okay, assume subroutine or function. Since this is a C class, I'll use the right terminology. So assume function, I don't know, match string is matches a string. Matches two strings. So what I can do now is to say, well, we'll just go ahead and call match string to get this done. But match string will have to come back with an answer of whether they match up or not. Okay? Because that really is the important part. So what I need to do is to say result is match string. And what am I going to pass to match string? Because it's supposed to match two strings. So what do you think it needs in order to work? How many parameters do you think it needs? It needs two parameters, right? The two strings that we're supposed to be matching. One is pretty clear, which one we need. Okay, needle is definitely one of the strings. What is the other one? Well, the other one is a little bit more tricky, isn't it? Because the other one is related to haystack, but it's not really exactly haystack either. Because if I just pass haystack to match string, and match string is going to match the beginning of both strings from the beginning of both strings, then it's not going to work because it's going to match from the very beginning of haystack and with respect to the beginning of needle. So what do you think I need to do to specify, hey, I don't want haystack. I want haystack only beginning at a certain point. That's what we want to specify, but how do we get to that part? Okay, let's think about this a little bit. Let's think about this particular thing. If I focus on this expression, what is it? What is the type of this expression? Is it a pointer? Is it an array? Is it a single character? What is haystack? Haystack is an array of characters. Okay. So if haystack is an array of characters, what is the square bracket operator? How do we call that thing? It's an indexing operator. And what is the purpose of an indexing operator? You can specify an element in an array, right? So that makes haystack open square bracket h pause close bracket a character. Okay. Well, we don't want to pass a character to match string because it's not supposed to match just one single character. It is supposed to see a string. But in C, what is a string? Tell me again what constitutes a string in C and C++. It's a pointer to characters that is null terminated. Okay? So how do I take this and say, well, this is a good starting point. This is in fact the very first character that I want match string to match with needle, but I also want match string to match the other characters after this potentially. Okay, so how do I turn this into something that is a string? I have a character already. How do I turn a character into an array? Address of, right? The ampersand symbol will do this. So we'll put an ampersand here. That's what we need. Is that okay? Any questions about this one? Yep. Because match string is supposed to be matching from the beginning two strings. So it will go, okay, the first character and the first character, second character and second character, and so on, right? but it will only match to the end of one of the two strings because we're not supposed to compare the null character of both strings. And that's why I cannot call string compare. Otherwise, string compare can do this, and I don't need to do a single thing myself. Okay, but haystack square bracket h pause is only giving me a single character, which is not what a match string is supposed to do. It is supposed to start with that character and then move on to the next one potentially, and then move on to the next one potentially. So the only way I can specify a parameter that can do that is to give it a pointer to a character, which is what I'm trying to do here. Okay. This, by the way, is top-down, design, because I am just, going to say, I will defer the logic of matching a string to another string, to another subroutine, to another function. I'm not going to specify that logic here. This will help to clarify the logic of string itself, and I just have to write the other subroutine later on. That's the whole idea of top-down design, is to say, okay, I know this chunk of code is going to be slightly complicated, will need its own local variables and whatnot, and may have its own loop. I don't want to deal with it now. Okay, so I'm just going to defer the writing or the development of that subroutine until later, and instead, in this code here, I just use a single function call to replace all that complicated logic that has to happen. Is that okay? I mean, are there any questions about the design philosophy itself?
Is needle also an array?
Needle is an array because that's coming from the man page, right? That's needle. Any pointer is an array.
So why don't we take the address of needle, the same like we did with haystack?
Because needle is already the address of a character. A pointer is a variable that stores an address. Okay. All right. So getting back here, this is for each iteration, we are going to do something like this. So how are we going to utilize result? So let's say, match string returns a 0 if there's no match, and it returns a non-zero when there is a match between the needle and the other pointer. Okay. So how am I going to use result here? Say again? Can you speak up a little bit? If statement, a conditional statement. Okay. So now, where do you want to put that conditional statement? In the loop? After the loop? How do you want to do it? Well, I'll give you some alternatives. Okay. So you can say, hey, there is a match. Great. Let's go ahead and just return something here. Okay. I'm not even worried about what I'm going to return here. I'm just asking, is this a good place to put a conditional statement to say, we found a match. Let's go ahead and return the pointer to the position in the haystack that has the match. Should we do it this way? Or should we do it over here if blah, 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 return a value that we are supposed to? How am I going to do this? Now, there are pros and cons to each approach. They both can work. It's just a matter of, if you choose this way, you're paying this price. If you choose the other way, you're paying the other price. So it's a matter of trade-offs. Okay? So I'll go through both options here. A lot of programmers will choose this way. In other words, as soon as they find an answer, they will say, oh, we got the answer. It's time to get out. Okay, we got the answer here. Why do we want to bother with anything else? Let's do a return here. So with that code, I'm even going to specify here what it's supposed to return. What it is returning is exactly the address of the first byte that has the match, which is exactly what we passed to match string. Is that making any sense? Because what is it matching? Which part of haystack is matching needle? It's the second parameter to match string. Is that okay? All right? Okay, but philosophically speaking, I have a problem with this approach. I personally do not like any type of return statement inside a loop, inside a conditional statement, inside anything. I want the return statement to be at the very end of a subroutine, at the end of a function. Because if I do something like this, and later on I have another return here, right? Because the loop has to exit at some point. In other words, if needle is not found in haystack, we'll still have, the loop will still exit. In that case, we're returning null, and if you want to return null, return 0 would do just fine. So a lot of programmers would probably implement this subroutine this way, to specify, hey, if we have a match, we'll just do the return right away when we find a match. If we do not have a match, which means we exit the loop because because we hit the null terminator of haystack, then it is a signal to say that we should return 0. This is not a incorrect implementation, but in the grand scheme of things, it is not a good way to deal with loops. Why do you think this may not be a good way to deal with loops, even though it is actually correct? What if the loop is a lot longer? In other words, instead of having actually just 5 lines of code in the loop, we have, I don't know, let's call that 20, 30 lines in the loop, okay, in this part of the loop, the body of the loop. Then how do you know, when the loop is going to exit? You're going to look at the exit or the condition of the loop to kind of get an idea of what would be the conditions to get out of the loop. In other words, to analyze the behavior of a loop, or at least what is true after the loop, you would look at this condition here and say, when this condition is false, we get out of the loop. Which also means, in order to continue execution after the loop, this condition has to be false. Is that making any sense? Okay. But when you have a return right in the middle of a loop, it breaks that type of analysis. Because what that means is sometimes this condition can still be true, and yet we are getting out of the loop. We are not just getting out of the loop, we're getting out of the entire function itself. Yep?
So what if you use the else statement and then else after that, so it's not good. If you use the else after that,
after what?
After if statement, you use the else for the another if statement.
I do not understand what you mean by that. You mean put an else here?
Uh-huh.
And what do you want to do in else? It doesn't negate the fact that we are having a return in the middle of a loop. And it will not only exit the loop, it will exit the entire function itself. And as a result, when you try to analyze the actual behavior of this loop, what we are really doing, you cannot just look at the condition of the loop and figure out, oh, okay, we are getting out of this loop when this condition is no longer true. You are basically looking at one part of the condition to get out of the loop, because the other condition to get out of the loop is specified with the condition of this conditional statement. And I personally consider this really not a good programming style, because the program would be more difficult to analyze when you try to analyze the program. And people who do this with a short subroutine will also do it with a longer subroutine. Okay, if you have a subroutine that has like 40, 50 lines and you do something like this, it makes the program a lot harder to read and to analyze. Okay, so that is the price that you're paying for something that is quote unquote convenient. This is certainly convenient, okay, from 2 perspectives. One is it gives you don't need a whole lot of lines, because if this is what you're going to do, we don't even need result to be here, right? Because what we can do is simply to put the entire call into this position, and we are done. I don't even need result as a local variable, because I can just use the return value of match string to determine, hey, is it time to quit yet? Yep, it is. We have a match. Let's go. Okay? So from that perspective, this code is shorter, it's more concise, but yet it is more difficult to analyze, and it is, to me, that's a big price to pay, because down the line, programs that look like this tend to be difficult to debug. Okay. So what about the other way? Okay, so what if we pay the price and say, okay, we'll pay the price, what is the payoff? Okay, what is the price and what is the payoff if we're not going to do it this way? Well, let's take a look. If we're not going to do it this way, then result will be needed in order to store match string. And this condition, to stay in loop condition, will now have to integrate result as a part of it. Okay. So result is really kind of a poor name for this one here. So I will just change the name of the variable to matched. Okay. So it's indicating, do we have a match yet at this point? Is that okay? Because the name of the variable should reflect what it is useful for. So now I have to say, what do you think would be a good initial value of matched? Should I start it off with something that is already matched, like matched equals to 1, or should I use a 0 to initialize it?
0.
Should be 0, right? Because until I confirm that it really is matched, I should say, well, I don't know whether it's matched or not. Okay, we'll just initialize it to 0. What about the stay in loop condition? How do I integrate match to the stay in loop condition?
Stay while matched is equal to 0.
Okay, and should I? Did you specify the connective? Like how do we combine the two conditions? And is correct. Okay, but I want to kind of mention that to the class here. We now have two conditions. Let me use extra parentheses to group these two, and I want the class to think about it and say, how should we combine these two? Because we got two options. Only one is right, but there are two options. One is to use the or, the other one is to use the and. Are we trying to specify another way to get out of the loop, or are we trying to specify, hey, we should stay in the loop longer? The purpose of matched is to get out of the loop earlier or later? Earlier. Okay, so if you're trying to get out of the loop earlier, because when matched is non-zero, we want to get out of the loop. Even though we haven't seen the end of haystack, it's time to get out of the loop. That's what matched is for. Okay, so that's why and makes sense, because when you have an and here, if any side becomes false, the whole thing is false, and we get out of the loop. Is that okay? And that's why and makes sense, because we are trying to get out of the loop earlier than without match equals to 0. Okay. And now when we get out of the loop, we have to find out how we got out of the loop. Well, matched is actually a good way to tell. So we can say if matched, we do one thing, else we do another thing. There are two ways to end, to specify the return statement. I can just do it the other way. Okay, so we can use a single return statement here, and it's going to be a ternary expression or ternary operator expression. We basically look at matched and say if matched is true, then we are going to return haystack hpos. Right? Actually, this won't work. I'll tell you why. The address of that. But even with that, it's not going to work 100%. I'll tell you exactly why it's not going to work. Otherwise, we return to 0. If it is not matched, I'm supposed to return null, which is basically just 0. Okay, so let's find out why this is not going to work. It's going to be off by, yep, go ahead. It's going to be off by 1 position. Hpos is going to be 1 more than what it should be. Why is that the case?
Because it's a for loop.
Because it's a for loop, so the plus hpos happens
After the body.
after the main body of the loop, and it is unconditional, so it is always going to be there. Okay, so hpos is always going to be 1 more than what it should be. Well, that's an easy one to fix. We just have to subtract 1 to counter that 1 additional plus that is unconditional, that always happens. Okay, so this is, go ahead.
Would hpos also be local to that for loop?
Hpos is, you are absolutely right about it. So we have to make a hpos not local to the loop itself and put it over here. So we have hpos and matched as not variables local to the loop, but it has to be visible to the return statement as well. Good catch.
specified like that.
Okay. Well, but this is using top-down design. I cannot run this code unless I have specified what match string is going to do. So let's go ahead and specify what match string is going to do. So now we have to look at match string and say, well, what are we going to do with this? What are we going to do with this? So it has needle, and I'll call this, part of haystack code. Because it doesn't see the entire haystack, it only sees a part of the haystack. Okay. It's supposed to return a 0 if a part of haystack does not match needle, and it's supposed to return a non-zero when the part of haystack matches needle exactly from the very beginning. So how are we going to do this? What about something like this? Okay, a single loop would do with a single index. We can say, for I is 0, needle bracket I equals to pole bracket I, and well, actually I should put it the other way. I'll explain why it is important. So we have to say needle bracket I does not equal to 0. We have not seen the end of needle yet. Okay. And needle bracket I equals to pole bracket I. I'll explain this later. And at the end of each iteration, we specify plus I, like that. That's it. That's the entire loop. There's nothing else to specify in this loop here. So let me move the screen up a little bit so the class can see it. There we go. All right. So let's see what this is actually doing. We initialize I to 0, which means we are starting from the beginning of both strings. POH, which is part of haystack, is a string, but it is a part of the haystack, but it is a pointer to a character, and therefore it is a string. It's an array of characters. Needle itself is definitely a string, okay? And I is the index to index into both arrays. So in this case, we are starting the matching from the very beginning of needle and also the part of haystack. And that's why it is initialized to 0. The first condition to stay in the loop is needle bracket I has to be non-zero. What does it mean when needle bracket I is 0?
We made a match.
We have a match, exactly, because we have seen the end of needle string, which means everything else, everything before that, has been matched already. So I have to say that this is important because I have to say we have not matched the entire thing yet. Okay, so now let's see what is next, what is in part of haystack, and see if it matches. And that's the second part of the conjunction, is basically to say if needle bracket I is non-zero, then we'll go ahead and see if it matches part of haystack at the same position. Yep.
What if you're searching for the character 0? Would it be the ASCII code for 0?
If you look, well, that depends on which way you actually mean. Okay, if you mean that you're looking for the digit 0 as a string, then you have to specify the ASCII code of 0 followed by 0 as a no terminator. If, on the other hand, your search string or your needle is actually an empty string, then it would just consist of a no terminator with nothing else. Okay. So if this entire condition is true, it means we haven't seen the end of needle yet, and up to this point, everything does match up. Well, what should we do in that case? Just add 1 to I and do this again. Is that okay? Well, by the time we get out of the loop, what is guaranteed when we get out of this loop? Once again, I could have included a return statement in the loop here, but I did not. So by the time we get out of the loop, what two reasons can be? Well, let me roll back a little bit. What is the condition by the time we get out of this loop? What is guaranteed to be false? This is guaranteed to be false, right? Because that's the whole definition of a for loop or even a while loop, is the condition has to be false in order to get out of the loop. Well, if this entire condition is false, there are several combinations of conditions or Boolean conditions that can be, false. Well, what if needle bracket I does not equal to 0 is false? What does that mean? Let me highlight the expression, and I'll ask that question again. What if this expression is false? And that is the reason why we got out of the loop. It means, sorry?
Needle equals 0.
Needle bracket I equals to 0,
Yeah.
which means what? From the context of this particular subroutine, what are we concluding?
You made a match.
We made a match. Very good. Okay, so that is good. So we say, if needle bracket I does equal to 0, then we have a match. Well, since we only have to return a non-zero here, one would do. What if needle bracket I is actually non-zero? Then what is the only other reason we would be getting out of this loop?
You find a match.
We found a non-match, right? We found that needle bracket I does not equal to POH bracket I, which is the other reason why we can get out of this loop. In that case, what is the actual conclusion? What is the semantics, the meaning of that conclusion? We do not have a match. And when we do not have a match, what should we return?
0.
Return to 0. So I just broke my own rule, didn't I? I said I do not like return statements in a conditional statement or loops and anything like that. So how do we turn this into something that is not like this?
Booleans.
Ternary operator. There we go. It would do exactly the same thing. It's just that instead of using a conditional statement to do it, I'm using a ternary operator and a return statement to do it. And now I'm not breaking my own rule of not having a return statement in the middle of a conditional statement or a loop. A conditional statement is not as bad, but it is still bad. But inside the loop, having a return statement in the loop is really bad, from the perspective of, how do you structure or analyze the program. All right, so I think we got everything. Do you? Are there any questions about the process of doing this? I cannot really explain, what went on in my mind when I came up with these algorithms. Okay, it's kind of like asking, Picasso. Okay, how did you come up with this idea? Right. So it's really hard to teach how to think. Okay, I think that's the best way to put it. What I did was I tried to structure it as much as I can, okay? Identify key elements, okay? And identify the key process. One thing you probably notice is I did not, except for match string, I did not write the code from first line to the last line in any subroutine. I kind of went back and forth a lot, right? That's kind of what you can expect as well, okay? Do not expect you can just kind of sit down and just write code from the first line all the way down to the last line of a subroutine, and then that's going to work, okay? It is not going to work that way, okay? You kind of have to go back and forth quite a few times, and a lot of times you don't even want to think in C code, write it down in any way that you can, okay? And then you want to structure it, okay? You kind of have to identify the key elements, like the conditions. What conditions are important here? What kind of action are important here? And then you just kind of move them around and go like, okay, but in what order should I do it? Okay, should I put the conditional statement in the loop, or should I put the loop inside the conditional statement? That sort of thing, okay? But you have to kind of, you can kind of envision it as having a, you're trying to solve a puzzle, okay? So you have all the key pieces of a puzzle, like a traditional puzzle where you have all the different pieces, of a big picture, and you have all the pieces already because you can do it by hand. If you can do it by hand, you have all the pieces, on a, in a box, but they're all kind of in random positions and they're not matching up. So what you need to do is to kind of identify all the key pieces. When you play, when you solve a puzzle, like a real, paper puzzle, how do you get started with a paper puzzle? You scan through every single piece and you try to memorize the shape and the pattern in each one in your mind. So now you have you have scanned like 2,000 of these little pieces, and then from in your mind you try to do the matching. Oh, I think this shape matches here and that pattern matches here and so on. That's not how it works, right? So how do you get started with a puzzle? Corner pieces, right? Because there are only 4 corners to most puzzles. Now, circular puzzles would be kind of difficult to deal with because they have no corners. And if all the puzzles are cut out in like a pie, that makes it even more difficult because now there's no rotation to rely on to say, well, I think this can only fit into these parts of a circle because it's a pie, right? Everything can be rotated and still look the same. But in most rectangular puzzles, you will first identify the 4 corners, and then after that, which pieces would you focus on? The edges, right? It's the same thing with programming. Okay, you identify the key pieces to basically pin down the most important parts of the structures, which typically would be the loops. Okay, so you identify. I think overall speaking, this is going to be a loop. That will pin down the 4 corners. But once you have a loop, you have to think about, but what would be the condition to stay in the loop? That's the other piece. That would be the edge of your puzzle. Okay, so you kind of think in a particular order to kind of make more details usable when you're writing code. That's kind of the process that I go through, but I cannot describe the exact process because sometimes the solution just kind of floats in my mind and go like, here's the solution. And I cannot describe that particular process, but if I have to make it structured, this is how I would do it. Okay. All right. Well, let's see whether this works or not. We have some kind of partial pseudo C code here, so we'll have to convert all of these into actual C code. But since we're halfway there already, I might as well just do it here, copy and paste it into the other document. We'll do it that way. All right. So we'll say char asterisk. Stir. This is my own, stir. It will take 2 parameters. First one is haystack, cons char asterisk haystack. The cons simply means that we are not supposed to change anything in haystack. That basically means this one should be const as well. Whatever is returning also should be a const pointer. The second parameter is const char needle. Is that order correct? I think it is correct, but I'm not 100% sure. I'll just switch back. Yep, haystack and a needle. Okay. And I would adjust the indentation just to make sure that everything matches up. When I look at homework assignments, sometimes I would see submissions where the indentations are all flush to the left-hand side, and those usually I look at those submissions and go like, it just makes me cringe. It reflects one of 2 things. Okay, I hate to put it this way, but it does reflect one of 2 things. It reflects either it was just copied and pasted from somebody else's homework assignment, because hey, I don't need the extra space, I'm just going to copy the code. Or it reflects that person is not really thinking in a structured way and just kind of doing everything in a flat way. And neither is good news. And match string is going to return just an integer. We need one extra close curly brace here. Nope, that one is not needed. That's all done. There we go. And to use my own philosophy, always use open and close curly brace. So when there's nothing to do, there will be nothing between the curly braces. All right, so I think we are ready to turn this into an actual program and test it out. So we'll do this, copy, and we'll do the usual thing here. Let's say cat to stir.c. It's just one little program to test whether it works or not. And then we have to go to stir.c and give it a main, okay, just so that we can run it and test it. So int main, and we'll do a const char asterisk result. So we'll test it a few times. Okay, we'll say test stir with a tag volume as haystack, and we'll try AK as the needle. We'll test it again with stir tag volume AK-47 stir tag volume, just a single U here. And I'll throw this in too, just to see whether you guys can think about this particular thing, which is an empty string, okay? All right, let's look at all of these cases, and we'll try to figure out what it should be returning. On line 32, which is the first one, it should return the address of what? My name is the haystack, AK is the needle, so what the address of which character should stir return?
The A intact.
The A intact, okay, very good. So that means if I print, result in GDB, it would actually print AK space AUYEUNG, because it will just print it as a string, okay? What about on line 33? It's looking for AK-47 in my name, and it should return 0, which is a null pointer, okay? On line 34, it is looking for U, and the address of which character should it return? The first U, so we'll be returning the address of this U here. When I say print result, it will print UYEUNG, because when you say print in GDB, when you're dealing with a string, it will automatically print everything up to the null terminator. What about the last one on line 35? I'm looking for the null string itself. A null string is not a null pointer, okay? Those things are two different things. A null pointer means it is the pointer itself is a 0. A null string is still an array of characters. In fact, it has exactly one character. Which character are we talking about? It's an empty string. It has just the null terminator itself. So it has no quote-unquote usable content because it just has the terminator. So how do you think it would match here? If you think of the algorithm itself, the match string algorithm, okay, let's scroll back to the match string algorithm, and I'll let you guys think about what it will be returning. If you look at match string, we have basically needle itself being, oh, that's not going to work. The syntax is off a little bit here. So we'll say const char star needle and const char star POH. Okay, there we go. What do you think will happen when needle is a null string, which means it is a string with just the null terminator itself, and POH is whatever. Okay, it doesn't really even matter. What do you think? It will return. Okay, let's go through the steps. Okay, initializing I to 0. Okay, fine. I is now 0. Needle bracket 0 does not equal to 0 is false. Okay, so I'm not even going to bother to look at the rest. I get out of the loop, so I get to the return statement, which has a ternary expression, ternary operator expression. Needle bracket I equals to 0 is true. That's the only thing in needle, okay, is the null terminator. So it does return true. Any string will match the null string. The null string itself will match the null string, but any other string will also match the null string. So that means the very beginning of my name will match the null string. It will return the very beginning of my name. In other words, the last result in the main program is going to be just a pointer to the very beginning of my name. When I say print result, it will print my actual entire name. Okay? But that's just my prediction, okay? When I say something like, oh, this program would behave this way, what do you do next?
Test it.
You test it, okay? You do not take my words for it. I have learned not to take my own words, so you should learn the same too. GCC or well, okay, we'll turn it into a C++ program because this is supposed to be C++ class, but all we are using are just plain C features in this case. So it is a regular C program. We'll shortcut the whole thing. So I'm not separating the compile and the linking process. I'm just combining them into one. Stir.cpp. And it complains about was not declared. Oh, okay, that's because okay. Well, that's actually not a bad thing. It's complaining, match string is not declared on line 10. How should I fix this problem? There are two solutions to this particular problem. I just want you to kind of think about it and tell me which are the two ways to fix this problem. It's complaining on line 10 when I first call match string, and the compiler says, hey, nobody told me anything about match string. I don't know whether this is the right way of using it or not. That's what the compiler is complaining. So go ahead.
We can declare the match.
Say again?
We can declare it.
How do you declare match string?
Prototype.
With a prototype, okay? That's one way to do it. The other way to do it is to move the entire definition of match string so it's before stir. So those are the two ways to do it. The easier way, obviously, is just to do a prototype here, which is basically spelling out how the function is supposed to be used, but not really moving the entire definition all the way up here. Okay, that will do it. And remember, when you're dealing with a prototype, the last character is a semicolon. It is not open and curly brace because that's the definition of a subroutine. Are we doing okay so far with this one? Okay, all right. Let's go ahead and recompile. And we have to run it through GDB because this program does not print anything to the output. So we're going to have to use GDB to help ourselves. Break on line 34. So let's run the program up to here. If you are not 100% sure this program is going to work, you might want to single step into the subroutine, but I'm somewhat confident this is going to work. So I'm going to do it next here, which means it will execute the subroutine, but it's not going to stop in the subroutine. Now is a good time to print result. This is after line 34, but before line 35. So when I say print result, which is a pointer to a character, it should print AK space AUYEUNG, because that is the first occurrence of AK in haystack. Okay, so that's my prediction. Okay, I think this is what should happen, and sure enough, that's what's happening here. Now we are going to next on the second line, which is line 35. AK47 is not a substring in my name, and as a result, when I say print result, it should return a null value. And nothing can be printed because the pointer itself is a 0, which does not correspond to a location where I can access. Okay, and that's why it's just saying 0. The pointer itself is 0, so it cannot print the actual content. Okay, now we're going to execute line 36. We are looking for U in my name, and there are two occurrences of U in my name. It should locate only the first one, which means when it's printing result, it should print UYEUNG. Okay, and let's go ahead and do that, and that's exactly what it does. And this is the last one, which is the most confusing one, where I'm passing the null string to as needle. Okay, the null string is, by the way, not the null pointer. I pointed that out a little bit earlier, but I want to point it out again. A null string is an array of only one character, which is the null terminator character itself. Okay, so my prediction is the empty string would match anything. In other words, it will match at the very beginning of the haystack in this case, and as a result, the result pointer is going to point to the very beginning of my name, and print result would print my entire name. That's exactly what it did, what it does also. Are there any questions about stir? Any questions about the C statements or features that I use in Stir, or about the approach of writing the subroutine. No questions? Okay. Let me just kind of go back to the editor so that you guys can take a closer look at the algorithm. Any questions about this part? Now, for those of you who had the idea of a double loop and not using match string as a separate subroutine, you can do that, okay? In other words, you can integrate the entire logic of match string into the loop that is on line 12 here. But what do you think it's going to do? What do you think that will do to this algorithm? It can be done, but what is the trade-off of using that approach?
Harder to read.
It will be harder to read, exactly. Because what you'll be doing is you are going to take this logic here, which is not a whole lot, okay? But you're taking this logic and putting it into, basically, right before line 12, and that's going to make the other subroutine stir itself more difficult to read, and you will have more local variables to track as well at the same time. So even though that implementation might be slightly faster or have a slightly improved performance, the price that you're paying is maintenance, okay? The ease of maintenance of the code. This one is, I think, relatively easy to read. There's only one thing that you're doing in the loop, and it's fairly clear what you're doing. And we are also helping to isolate the bugs, okay? Because if I did, put a bug into the subroutine match string or into the logic of match string, when I test match string all by itself, I would have been able to locate that bug, and it would not be complicated to solve the problem. On the other hand, if I take all the logic in match string, which is here, and put it into stir, and there is a bug in that logic, then I have a lot more code to consider when I'm trying to debug my program. It will be much harder to locate that flaw in my code if there was a flaw. Unfortunately, I did not actually write a flaw into this program. You would not hear that very often, okay, for someone to say, unfortunately, I did not actually have a bug in this program. Because if I did have a bug in the program, I would have been able to illustrate, hey, if I have a bug in the subroutine, I can test that subroutine all by itself and just see what is the problem. Do you think it will be complicated to debug if there is a bug in match string? Probably not too hard, because this code is relatively simple. But if I put this code into stir, then the total number of lines of code is going to be increased, and the bug can be anywhere. And that's why using subroutines is going to be helpful in terms of locating and isolating bugs, because you can test the subroutines all by themselves to make sure that one subroutine is working 100% before you even rely on that subroutine in another subroutine. That's basically another attribute of top-down, useful attribute of top-down design. Are there any questions about this class? The whole thing about writing the code, developing the logic, stuff like that. No questions? Well, since you guys are in this class, I know some of you have to be in this class because your major says you have to take cisp360. But for the rest of you, you're here because you want to be in a computer science program. But when you're dealing with homework assignments or something like this, what I did today, which part of this process was the most enjoyable part of it? Like, this is exactly why I'm going to be a computer science major. If computer science is not your major, you can still let me know of your opinion. Even though it's not, it may not be something you can basically say this entire process is not enjoyable to me. That would be one possible answer. But for those of you who want to be in a computer science program, some part of this process has to be a enjoyable kind of process, and that's why you want to be a computer science major. And not just, well, everybody I talked to said, computer science is a good occupation. And when I look up, the Bureau of Labor Statistics, the pay scale seems to be pretty good too. those would not be exactly good reasons to pick computer science as a major. Okay, so having said that, yep.
I like the part when your code finally works.
That's a good part.
Well, that would be the very last part if it happens. I was thinking, should I use if or when? Nah, if. Okay. What else? Yep.
I enjoy the problem solving.
You enjoy the problem solving. So when your program actually does not work, you're still problem solving to find out.
From the get-go, it's just when I have a problem in front of me,
Mhm.
I've got a starting point and a middle point, and I don't know the starting and end, and I don't know the middle. I just enjoy sitting down and trying to work through everything.
Trying to figure it out, right? That's good. That is good. How many people enjoy the debugging process all by itself? Some of you, very good. Okay, that's actually surprising because most people despise the debugging. When the program do not work, they go like like that. But debugging to some people is actually a fun process, especially when there's no due date. Yep.
Debugging is more fun for me than doing puzzles or
It is a very you have to focus and apply logic, when you're debugging. I know we are kind of running out of time. I was a TA at UC Davis when I was a grad student over there, and I was only a TA for 1 year. And I was assigned to a computer lab, because TAs are supposed to help out the students in the computer lab. And right before a homework assignment was due in the computer lab, you'll see a lot of frantic people, trying to get the homework assignment done. And in the process of trying to get the homework assignment done, I have observed, people, and these are UC Davis, students in the computer science program. I have observed people who would do random changes to the source code and hope that one of these random changes will fix the problem. They kind of guessed the problem has to do with, oh, I'm off by 1, or this instruction should be like one line before the other one, and so on. So they would just kind of do random changes without thinking it through, or think, okay, if I move this line, how would it change the algorithm? They would just do it, recompile, and run the program. Oh, it crashed again. Okay, time to make another random change somewhere else. And that just made me go like, because it's making things worse, not any better. So if you enjoy the debugging process, that's probably not what you're doing. You're just kind of sitting down and go like, okay, why is this not working? And the best tool to help you in that process, obviously, is GDB. Okay, so that's really nice. I'm kind of encouraged that many of you enjoy the actual debugging process. Do you think that's going to be helpful when you are first employed by any type of software company? What do you think will happen? What do you think is going to be your first job? Fresh out of college, you apply for your first job. Do you think they're going to assign you to a team and say, you know what, I want you to be the architect of the next Google, whatever, application? That's not going to happen. What do you think they're going to let you do? Clean the toilet with a toothbrush, right? We're not talking about pressure, washer here. We're talking about the toothbrush. That's what you're going to use, okay? Now, not literally, but you'll be doing the equivalent to fixing bugs in established code, right? So you'll be looking at some source code that somebody wrote 20 years ago, and that person does not even work for the company anymore, and there's no comment whatsoever anywhere in the code. And your job is to say, fix it, okay? This is the problem, okay? They will give you a ticket that will describe how to reproduce the problem, okay? So you go through the process and go like, oh, okay, the program does crash exactly as it describes, okay? Now it is your job to fix it. You open up the source code, and it's like 20,000 lines in one single file, and the function, they're all about, 100 and 200 lines long, all written in C in a very, convoluted way, because there are ways to write programs in a very convoluted way. No comments, and your job is to figure out why the program crashed and fix it.
Wait.
Yep.
Can you, I thought that's not possible, that you write a program for a company without comments.
Not 20 years ago. And that employee is long gone by now, so there's no way to grab that person and go like, you did not leave any comments, you have to explain that to me now.
Okay.
That person has retired or even passed away. Yeah, if you're talking about the COBOL program, that particular program might have passed away. Yep. So that's why, if you enjoy the process of figuring out something, why is this program crashing? You will enjoy that job from the very beginning. A lot of people figure out that, hey, I really hate computer science, after they get the first job, because they don't get to write their own programs. They get to fix the bugs of somebody else's program. And to some people, that is not enjoyable. All right. Well, that's the end of today's lecture. We are going to, in the next class, next Monday, we are going to go back a little bit, because now that we have some programming experience under our belt, we are going to go back and talk a little bit. It's a soft topic as far as I'm concerned, but it's under program development. Okay, we are actually going back to this particular topic to talk about how to write a program, software specification, and stuff like that. Because if I talked about this from the beginning part of this semester, most people just go like that, right? Because until we have done some programming, there will be no appreciation of any of these particular topics. So we're going to go back to this topic now that we have some programming experience, and kind of re-emphasize some of the points that are important when you are developing your own code. So that's it for today's lecture. I will stay here for if you are working on your homework assignment and answer questions. If not, I will see you next Monday, and have a nice weekend. I know it's weird, it's only Wednesday.